Good morning, this is Javier Fernandez from the Reuse Company, and I'm going to introduce you the measurement unit for a specific property consistency metric provided by the RQS 15.1. This metric is based on natural language processing operations, which means that it will check if requirements from the same specification use different measurement units, like kilograms, pounds, for a specific element's property. It is very similar than the measurement unit consistency metric, but this one will detect measurement units inconsistency for a property of an element selected by the user. For instance, if the specification is talking about the capacity of the fuel tank, will it be in liters or centiliters or maybe in cubic meters? If it is talking about the weight of an aircraft, will it be in kilograms or maybe tons or pounds, etc. It will return a percentage value from 0 to 1 representing the inconsistency ratio for those requirements involved by the metric. For example, using different measurement units for the same element of a property, we are saying that the capacity of the fuel tank must be in liters. So having this specification, we notice that there are different units for the same property of an element. In this case, it's going to be the capacity of the fuel tank. So the metric will score a 75% of inconsistency, which means that 3/4 of the specification have inconsistency issues. The way that this metric works is having the following knowledge assets stored in the system knowledge base. First, we need a pattern which must be defined to match requirements with this structure. The physical characteristic of the element shall be number and unit. And then a formal representation as a property which must be created from the pattern to produce actual properties. This process will be done in the knowledge manager. Then it will be compared with the properties found in the specification. This last process will be done by the RQA. Notice that we will need 3 different properties to define. First, a physical characteristic, in this case it's capacity. Then we need an element which is a fuel tank, and finally we'll need a third property defining the unit. In this case it will be liters. So now it's time to create the pattern, the requirement pattern, and then the properties for in order to create the metric. So first, in Knowledge Manager, I have created 3 different clusters, term clusters. One for property and physical characteristic, containing all these physical characteristic terms. A second one for system, and then another for system element. And the last one for measurement unit. Now, if we go to the pattern section, I have created this physical property, which is a requirement pattern. Remember that the way to create patterns in Knowledge Manager is providing a real example. Then I define this slot as the semantic cluster I showed you previously, which is property and physical characteristic. Then a system or system element in this slot, and finally the semantic cluster for units in the last slot. Notice that if we select these 2 semantic clusters, we will need to create 2 different properties, one for system and one for system element. So it's time to create the properties. So go back to Knowledge Manager, and in the Formalization tab, the Property Formalization section, we select this button and we double click on our pattern. As you remember, we need to create 3 different properties. The way to create properties is as defining an attribute and then a value, selecting before the operation type. The first one will be system, which must be equal than the slot on our pattern, which is property and physical, system system slot. Okay, as I told you before, we need two for system. One for system and one for system element, since we have two different semantic clusters. Then we need a physical characteristic property. And it will be equal than the slot, property and physical characteristic, which is in our pattern. And finally, we need a last but not less important property, which will be the unit used by the requirement, which must be equal than the slot in the pattern unit. Now we have the patterns and the properties defined in Knowledge Manager. So now we can go to RQA and define the metric. But first, remember to always to save the assets in Knowledge Manager and then reload the ontology if RQA is open, in order to reload this information we just created. Go to Project Configuration and Consistency button and create a new metric, in this case measurement unit for a specific property. Provide any name and any description. You can also apply a filter using attributes in your requirements management system, and then configure the metric using this button. The way to configure the metric is just selecting the system, selecting the properties we created in Knowledge Manager. In this case is system, then physical characteristic for the characteristic property, and the unit used is going to be the property we created before for unit. You can also filter elements, but this is an optionally feature. Now you have the metric configured, so you can you need to provide the pattern we created in order to match requirements. Okay, and accept, and the metric will be created. The way to calculate the quality for this metric is going to quality control and then consistency button, right click and clicking on recalculate quality. Let's see what are the results of this metric. Why is the reason that this metric scores low quality? If we double click on it, the following screen will show up. In the metric result tab, we will see the main consistency assessment results in two different ways. First, the requirement specification inconsistency, which is the rate of requirements with elements properties selected in the metric configuration, which have in green and have not in red consistency issues. In this case, 22% of the requirement with properties have consistency issues. Then we can see the inconsistency in measurement units used in the properties of the elements, which is the array of elements properties which have in green and have not in red measurement units consistency issue. Let's see which issues have been found. In the Issues tab, we will see the set of elements properties which are involved in the consistency assessment. The assessment is saying that the property size of term missile is expressed in two different units. If we double click on it, we will see which requirements have inconsistency issues. In this case, there is a requirement saying that the size of the missile shall be 1 meter, and another one saying that the size of the missile shall be in 3 yards, which is not good. Then the requirements tab will show a set of requirements which are involved in the consistency assessment. Notice that these are the same results, but from a requirement point of view, from a requirement approach. So we see the two requirements with consistency issues, which we can open the issues from here, or even edit the requirement if we want, using the requirement edition window. Then the measurement units by element tree will show you the requirements sorted by inconsistent units in the elements properties found in the consistency assessment. In this case, the only element with conflicts in the specification we have found is missile, and the property in this case is going to be size, and the two conflicts we have, the metric it has detected, is in this case meter and yard. If you still clicking, you can see which requirements have these inconsistent issues. Finally, the filtering tab will show you the set of all requirements in the specification, not only those filtered when with attributes in the metric configuration. If you want to save this quality information, you can use this button to create reports, which automatically will create a document easily exportable to an Excel, PDF, or Word file. I've been Javier Fernandez from the Reuse Company. Thank you for watching.